So moving forward in the lesson, it's just continuing evaluating, but we're dealing with a few different types of questions. So now instead of just a logarithm, we have a coefficient 2. Jackson. So we're going to leave that 2 out front. And we're going to set this equal to x. Okay, so 2 times whatever this is equal to. So let's just do that separate to start. Okay, so we have log base 8 argument 512 equals x. And then we change it to exponential form. So we have our base 8 to the power of x equals 512. From here we need to get a common base. So help me out, 8 to the power of what is 512? I see a 3 over there, good job. Okay, and now that we know we have the same base, we can set the exponents equal to each other. So x equals 3. Well, log base 8, 512 was equal to x. Okay, so now what do we have? We have 2 times 3, which is 6. Good. Guys, the other way we could have done this is we could have set this equal to x right away and then divided by 2. And then you could have written it as 8 to the power of x over 2 equals 512. And then 8 to the power of x over 2 equals 8 to the power of 3. Exponents equal, x over 2 equals 3. And then you just have to multiply the 2 up. So you could have done it either way. Okay. Now some are saying if they don't do it this way, they might forget about the 2, so you get to choose which way you like better. Next one, let's set it equal to an unknown variable. Again, I'm just going to choose x. We have base 2, raise it to the power of x, that's going to equal 1 over 32. So we have it in exponential form, but now we need a common base. We have 1 over 32. Right now, let's just forget about the fraction. Let's just look at 32. Is there anything we can raise 2 to get 32? 5. Good. Now, how do I get 2 to the power of 5 out of the denominator?
-5.
Good. We change the sign on the exponent. 2 to the power of -5. So now we see that x equals -5. And what was the logarithm originally equal to? X, so we say log base 2 of 1 over 32 is equal to -5. Anytime you have a fraction like 1 over something, you'll have a negative. The exponent had to be a negative. Okay, next one, we're going to set equal to an unknown again. So we have 5 to the power of x is equal to the square root of 125. We need the same base. So before I deal with this square root, how can I change 125 to base 5? Power of? 5 to the power of 3, good. Now, do you guys remember how I could rewrite the square root as an exponent?
Oh yeah, 1 over 2 or something.
Yep. Okay, we have 5 cubed, but the square root could be written as a half, so to the power of a half.
I like it.
Okay, if I had the nth root of x to the power of n, that's the same as writing x to the power of n over n. So if I had the square root of 125, my index is this imaginary 2, my exponent is this imaginary 1, so I have 125 to the power of 1 over 2. And we've rewritten 125 as 5 cubed, and the half is just coming from the square root. So we have 5 to the power of x equals 5 to the power of 3 over 2, which means x equals 3 over 2. if I were to evaluate the entire logarithm, I would say that log base 5 of the square root of 125 equals 3 over 2. So more fun and more practice. This time they're putting the logarithm in the exponent. We have 5 to the power of logarithm 525. Okay, so if we're supposed to evaluate this, we first need to evaluate what that single logarithm in the exponent is worth. Okay, so we're just going to take this for starters and we're going to just evaluate what log base 5 argument 25 is equal to. So it's as if we're rewriting 5 to the power of that as 5 to the power of x. We got to figure out what does x equal. So we rewrite it in exponential form and we get 5 to the power of x equals 25. Now I have a question. You look at that, do you have to change it into the same base to figure out the answers to? No, we should know 5 squared is equal to 25. So x equals 2. And you are going to get really good at this, so you can just look at it and go, oh, that's 2, that's a 3. You'll be quicker and quicker. So if x equals 2, that means we're replacing the x now with 2, and we get 5 squared is 25. We've seen some lost spaces. We first evaluated what log base 525 was, okay, and we set that equal to x. We figured out what x was by changing to exponential form. We get 5 to the power of x equals 25. 5 to the power of what will give you 25? 2. So this is worth 2. So we have 5 squared now, and that equals 25.
Why did you make it equal to 5x?
Because I need to figure out what log base 525 was. So instead of having this, I set it equals the unknown variable x. And then we figured out what that x equaled, and I just replaced it in. So in order to evaluate this, in other words, you need to figure out what does log base 5 argument 25 equal. Just like we were doing in the last questions, we were evaluating without that 5 there. We're just evaluating what logarithms were worth.
Yeah, because you made that x.
Yeah, so I've made this exponent, log base 5 argument 25, I set that equal to x. And then I figured out, well, what does x equal? And once I found that out, I plugged it back in.
Okay.
We're going to do a few more like exactly the
I
same.
I get
So
it.
let's try this next one. Okay, so we have log base 7, 49. Before we can evaluate this, we've got to figure out what does that logarithm evaluate to? What's it worth? So we have to figure out what it is. So we're going to set log base 7, 49 equal to an unknown variable. Then we're going to raise 7 to the power of x equals 49. If you want, you can change the base. Or you could have just right away figured out x equals 2. Okay, x equals 2. If I just go back up to this first statement, Joe, remember I said this equals x?
Yeah.
If x equals 2, I can put that this equals 2 now, right?
Okay.
So I can replace this with a 2. And if I evaluate 7 squared, I get 49. That's my final answer. Okay, so in the first question, my answer was 25. In the second question, my answer was 49. Let's just take a look here. So the base in the exponent is the same as the base in the logarithm. And it equaled the argument. let's check out this one. The base in the exponent is the same as the base in the logarithm. What did it equal? The argument. So if the base of the exponent is the same as the base in the logarithm, what's it going to equal? It's going to equal that argument, 27. And that's actually an observation that we're going to summarize. So if you have log, or a to the power of the logarithm, a, with an argument n, that's always going to equal whatever your argument is, n. Okay, so could you guys write that out, please? Similarly, when you're taking a logarithm as your exponent, where the base is the same, if you take a logarithm of a base a with its argument also as a base a raised to the power of n, it will also equal n. And I'll just give you an example. I'll show you how it works. If we set that equal to x, we now have a to the power of x equals our argument a to the power of n. Okay, just take your base, raise it to the value, and that will equal your argument. Same base, so we set the exponents equal. And we see that this actually equals n as well. Okay, so the other one is that log base a, argument a to the power of n, is also equal to n. The reason why this works is because exponents and logarithms are inverses of each other. So if you're inversing each other and you have the same base, it's always going to equal, in this case, the argument, and in this case, the exponent. And if you're ever unsure, just evaluate. Okay? So now we're introducing the log key on your calculator. So there's some questions where you're going to get to and you're going to realize, I can't actually solve for that one by finding the same base. For example, if you take log base 5, argument 50, we're going to have a bit of a problem, and I'll show you why. Okay, so if we set log base 5, argument 50 equal to x, and then we convert that to exponential form, we get 5 to the power of x equals 50. Can you convert 50 to base 5? No. So we can't change to base 5. And if we can't have a common base, then we can't set the exponents equal to each other and we can't solve. So before I teach you something on your calculator, we're just going to estimate what we think this would equal. Okay, we need 5 to the power of something will equal 50. So let's just start with our exponents. If we go 5 to the power of 1, we get 5. 5 to the power of 2, we get 25. 5 to the power of 3, 125. So we know for sure our estimate of what x will equal will be between 2 and 3. Okay? 25, 125. We want to get 50. So maybe let's try 5 to the power of 2.5. If you guys evaluate that, what do we get?
55.9.
A little louder, sorry?
55.9.
55.9. We are getting really close. Okay, but we're not exact. Do you guys really feel like playing around with these exponents and going 5.53 or 5.487? Do you really want to do that? Probably not. So what we're going to do is we're going to introduce the common logarithm, and it's a key that we can use on our calculator. One thing that's important to know about this is that it'll always have a base 10. Okay, for example, log base 10 of 1,000. Okay, Note that log base 10 1000, you will often see it written as just log 1000. If there isn't a base written, it's assumed that there's an imaginary 10 there. Okay, so always remember if there's no base, it's actually a 10. So let's just try and figure out what is log base 550. Actually no, we'll get to that in a second. We're going to practice using our log key and then we'll go back to questions like that. Okay, everyone got their calculators out? If you haven't found the log key yet, it's right under the square and the square root button. It's right here. Right beside the number 7. So we're just going to evaluate what is log 1000. And it's 3. Now, if I were to solve this using exponential form, I first want to note that this is imaginary base 10 right there. So log base 10, 1000, we set it equal to an unknown number, a variable. Then we change to exponential form. We get 10 to the power of x equals 1000. Then we convert to the same base. And 10 to the power of 3 gives us 1000. And once we have the same base, we can set the exponents equal to each other. Well, log 1000 was equal to x, and we figured out x was 3. So, pretty safe to say that log 1000 is equal to 3. And on our calculators, we just press the button log, and then 1000 and enter. That also equals 3. So as long as your base is 10, it saves a little bit of time to just press this than to go through all those steps. So carrying on, we have a few examples at the bottom. We could estimate, but we did that up top, and we know that it would just take a little bit of time to get that exact value. So let's look at log 89. You're going to put in your calculator log, and then 89. Stan, what'd you get?
1.949.
Okay, and we want to the nearest hundredth. So 1.95.
Oh, yeah.
Yeah. Okay, now let's evaluate log 2000. So literally just putting in log 2000 into your calculator. And Xander, what'd you get? Good. So we get 3.30. So there's a natural logarithm that also can be used as a common base rather than 10. And that base would be base e. Okay, so for example, you could have logarithm base e of 15, argument 15. E is considered a rational number. If we were to do the enrichment below, you would see what that value actually is. But that's something that you would learn in higher level courses, and it's not necessary for Math 30-1. So we're going to skip that, but I am going to introduce you at least to what the long key does, just so you know how to evaluate it if you come to questions like that. Okay, so just to note here, if we have log base e, argument 15, that can be written as ln 15, okay, assuming that the base e is being used. So the ln key is right below the log key. Okay, so ln, for the ln key, it's right below. And if you were to evaluate ln 5, You put in your calculator, ln 5. Okay, what do you get? 1.6? They just want one decimal place. Okay, how else can we interpret log base e argument 5? Good, log base e is the same thing as writing ln. So this is also ln base 5. That equals 1.6. And then lastly, yeah,
What if you had to do it with a different base?
we're going to get to that next. Yeah, good question. Then the last one is ln e. So you would just press ln, and then you'd have to go second for your second function,
E.
and then e. And you get,
Wait, second or
I'll show you on my calculator. So you go ln, and then second, and then e is the division symbol, right? You plug that in,
this one?
press enter, and you get 1. Okay, so maybe I'll say that it's the division symbol because technically e is the second function on that key. Now you're not going to see too much of this type of question, but I just wanted you to be exposed to what ln meant or how the base and the ln key can be interchanged in case you do see it. Alright, so now going on to Emily's question. What if you have a different base? For example, base 5 and argument 25. Well, we'll convert that to exponential form to start. Okay, so log base 5 argument 25 equals x. Then we're going to change it to 5 to the power of x equals 25. So it's now in exponential form. If we were to solve from there, what does x equal? 2, good job. Now what we're going to do is evaluate log 25 divided by log 5. We're going to see if we get the same answer. Just to note, because it will come to it later on in the notes, but a few students ask, well, how are they getting the 25 and the 5? It's always going to be the log of the argument in the numerator divided by the log of the base in the denominator. Okay. So on your calculator, to evaluate this, let's clear that out, we're going to go log 25 divided by log 5. Okay, then you press enter, then you get 2. So I think for part 3 we can comment that they're the same. Okay, how about if we try part B? We have exponential form and calculator form. So we would write it as 3 to the power of x equals 243. And 3 to the power of what gives me 243? 5, I think? Just help me out.
5.
Yep, 5. So that logarithm is equal to 5. Now we're going to evaluate with our calculator. We're going to go log 243 divided by log 3. Press enter. We get 5. Yeah, Bernie?
Sorry, no, I was stretching.
Oh, good stretch.
Yeah.
Good stretch. Hey, again, they're the same. So what we can conclude is that we can change the base of any identity and then evaluate it using our calculator. Okay, so if you want a little help with this identity, just remember that the numerator is your argument. Argument. Did I spell that wrong? No E, right? No E. Looked funny. Okay, and then B is our base. Okay, so we always go the log of our argument divided by the log of our base. Do you guys think it matters what base we have? Like whether it's a 10 or a 5 or a 3? We're going to find out. Okay, so if we were to evaluate log base 4 of 1024, we would just rewrite that as log of our argument divided by log of our base. Okay, so if we evaluate that on our calculator, what do we get? Log 1024 divided by log 4. Bruce, what do you get?
Pardon?
Pay attention.
5.
So you're putting this in your calculator. Log 1024 divided by log 4. Jackson, you should do it too. What do you get? 5. Very good. Okay, now I just overheard a question. Does it make a difference if we put this all in brackets or not? So let's just try it. This is how I would do it. Log 1024, close the bracket, divided by log 4. And then I'm pretty sure this was the question. Can you just go 1024 divided by 4? Guesses? Same or different? I'd say different. Okay, so please make sure that you're writing them as 2 separate logs. So, what base is on this log? On this one right here, just the numerator. What's the base? 10. What's this base?
10.
You see how we changed the base to base 10?
Yeah.
Okay, in this example, we have basically what we wrote here, but our bases are 2's. So I'm going to expand this and we'll see if it makes any difference. Okay, so you can watch or you can write, doesn't matter. So we have log 1024 divided by log base 2. That's just the numerator. This is just the numerator. Then we're going to divide that by the denominator. Log of our argument 4 divided by log of our base 2. Do you guys remember kiss and flip? Multiply by the reciprocal? If I were to multiply by the reciprocal of this, log 2 would be up top, right? What would happen to log 2? Cancel out. So if I build that out, okay, would it matter what base I put there? Whether it's base 2 or base elephant or base rhinoceros or base like 36? Does it matter what that base is? No, because that's going to be canceled out. And then we just end up with what we had over here. Okay, log 1024 divided by log 4. We're still going to get 5. So if you see in the event that you have the same base, skip writing all this out and just jump to this. Okay? We're going to carry on evaluating, and we're just going to change the base to base 10. So that's the easiest way to go about it. So we get log 221 divided by log 5. What base did we change it to? 10. And then you just plug it in your calculator. Log 221 divided by log 5. What do we get?
3.35.
3.35. Yeah. How do I know? It actually doesn't even have to be base 10. It could be 7 or 35, it doesn't matter, but on your calculator, what is the base always assumed to be? 10. So if we want to use our calculator to solve these, then we assume it's base 10.
Okay, so you just have to give them any number that is the same.
Yeah, yeah.
Okay. I get it now.
Junior class change.
Okay, next one. Just keep in mind, we're basically solving for what x equals, just now we're not putting it into exponential form. Okay, so in this case, we're going to go log of our argument, 1 over 1,000, divided by log of our base, 2. And just make sure that 1 over 1,000 is in brackets. What did you get? Perfect. Okay, that equals negative 9.97. Notice again, we have 1 over something and we get a negative. Any questions? Okay, the last one, the only difference is we have a coefficient out front. So we're just going to leave that 3 out front, and we're going to multiply it by log 512 divided by log base 7. Okay, so log of our argument divided by log of our base. I'd recommend evaluating your logs first, and then multiply by 3. So we do log 512 divided by log 7, then multiply by 3. Emily, what did you get?
I got
9.62, brilliant. Before you guys move on, there's just a few more questions on the last page here. I want you guys to go to the back of your workbook. Mine's in my front, but yours will be in the back of your workbook. There's a formula sheet. And this is what you're going to get on your diploma. This is what you'll get on your midterm. I want you guys to look for exponents and logs. Did you guys see the change of base identity? Okay, so it's the last identity on exponents and logs. Okay, that's the change of base one. So remember how we talked about it doesn't matter what base you have? In these next questions, they're telling us what base to go to. But it still won't change how we calculate it. Okay, so in this case, they're telling us that we need base 3. So we're going to write log 216 over log 6. And what's our base going to be? 3. Does it matter? No, because log 3's would just cancel out anyways. So really we're just evaluating in our calculator as log 216 divided by log 6. In this case, they're not asking us to evaluate, but if you did have to evaluate, you just go log 216 divided by log 6. Okay, next one's base 5. So, what's the imaginary base in log 300? 10. So we would write it as log 300 divided by log 10, and our new base is 5. On your calculator, you could still just put it in as log 300 divided by log 10. And just a few more questions to practice here. This one, the only difference is we're going to multiply it by a negative. Okay, we already looked at multiplying change of base identities by 3. Now we're just going to multiply it by a negative. So it'd be negative out front, and then we're multiplying by log 1 over 343 divided by log 7. So we need to evaluate as an exact value. So no decimals, no fractions. Who's got this one? Just shout it out. -3? The +3. Good, because the logarithm, notice we have 1 over something. That's going to give us a negative. And then negative times negative is positive. Okay, next one, what we have to do is change the base on those ones. So we're going to have 6 to the power of log 216 divided by log 6. Do you guys remember if the base and the base are the same, what it equals? $216? Yep. Okay, but if you're unsure, you can just put that in your calculator. Okay, but our answer will be just 216. Okay, if the base on the exponent and the base of the logarithm are the same, you just take the argument. Okay, next one. Log of the square root of 1 over 1024 divided by log 2. As an exact. Remember, brackets are important. What'd you get? Huh? You gotta practice it. Nolan, what'd you practice? Okay, if you have it, what'd you get?
-5.
-5, good. Okay, I'm gonna just throw a curveball at you and see if you guys can figure this out. Is the base and the argument are the same, right? So what's it gonna equal?
-10.
Yeah, exactly. But if you're unsure, you can go log 49 to the power of -5 divided by log 7, and you should evaluate that as -10. Okay, see how those exponents are actually -10? So once you get good at these, you'll be able to just know them without even using your calculator. So we feel good?